Today we are going over lesson 5.1 and just giving an outline of the chapter here. We're dealing with generally the centers of triangles in this chapter. So the first 4 lessons we'll be talking about different centers of the triangle, such as terms like circumcenter, incenter, orthocenter, and the centroid. All these have different theorems involving them. And so that's what we're going to be going through today. We're going to be working on the mid-segment part of things, and then we'll be switching to talking about coordinate proofs. And if you kind of see at the end of the chapter, we also have indirect proofs. And so we will get some proofs in, but they're definitely going to be different variety than we are used to. And so starting off in this chapter, we get the mid-segment theorem. Mid-segment is a segment that connects midpoints of the 2 sides of the triangle. So in this picture here, D and E are midpoints because this DE is a mid-segment. Now, from a mid-segment, we have 2 things. We have, midpoint, so we're getting some congruent marks on both sides of the triangle, and we're also getting that the mid-segment is parallel to the side that it doesn't touch. Secondly, this theorem tells us that the mid-segment, this side is X, the side is parallel to is twice that length. So AC is half of AC equals DE, or again, if you don't like fractions, you could rewrite this as 2 times DE will get you AC. So some math involving that. We've got a picture here of kind of what trusses are, right? They usually hold up the roofs of houses. So triangles are used for strength in these situations, and the diagram UV and VW are mid-segments, right? So just from that information, we could label a bunch of congruent marks all over, right? Now, I didn't even label the congruent marks from my mid-segment. So now it says find UV and RS, right? I didn't label UV and I didn't label VW. So UV, right here, right, this segment equals half of the segment that's RT. Well, RT is 90 inches there in the diagram, so it's half of 90. I get 45, so UV is 45, and in this case it gave us inches. So UV is 45 inches. Next, what is RS? Kind of working left to right here a little bit. RS is, again, this segment here. What is that equal to when we have VW? The mid-segment is 57. So, right, again, VW equals half RS. Well, in this case, we know what VW is. 57 is half of what number? So you got to multiply by 2 on both sides, right? You kind of cross-multiply this 2 up to get 114 is RS. But this 2 over here would cancel. The other one, so 114 inches is RS. And now kind of snuck in there is what is the third mid-segment, right? So we have one mid-segment here, another one here. If we know U and W are midpoints, our third mid-segment, which isn't in the picture, is UW. And then conveniently, if UW is 81 inches, how long is VS? Now hold on, you got to look at your diagram. It is not the exact same as what these are talking about, right? So let's look at the information we have, right? So far we have this segment down here was 90. It was cut into 2 equal pieces by W. So both of those were 45, as we found out. UV was 45. Next, we found out this one's 57, and both of these over here were 57 to add up to 114. So now they're saying this one's 81 inches. What is this piece? They didn't ask for the whole side, they just asked for half of it. This side is going to be equal to 81, right? Now again, mathematically, you could have set it up that UT, half of UT equals UW, but the problem is, right, once we figure out UT is 162, we then have to cut it in half again, because we were only looking for half, right? VS is half VT, so we basically be cutting that 162 back into that 81-inch size. Moving on. Next, this is the most common math you'll see with this. This is something you'll need to know how to do on quiz and potentially test. Use triangle DEF where A, B, and C are midpoints. Right? Given AB is 3x plus 8 and EF is 2x plus 24, what is AB? Okay. Now, remembering what we just went over, right? AB is the midsegment, right? I didn't tell you that. I gave you the midpoints. So that means AB equals half of EF, or again, I like to use nice numbers here, so I'm generally going to write this as 2 times the small one equals the large one. Right? So this is the way I'm going to generally use it to solve, and I have the information. You've got to plug it in. 2 times 3x plus 8 equals 2x plus 24. A little bit of algebra will give us 6x plus 16 is 2x plus 24. Minus my 2x, minus 16 for both sides, giving us 4x and 8, and x is 2. Now, did they ask for solving for x? No, it asked for what is AB. So you've got to plug it back in. So I'm plugging in 2 right back into there. AB equals 3 times 2, 6, plus 8, giving me 14 is AB. And if you need more time to write some of these notes down, feel free to pause at the end of the slide. So that'll give you some more time. So one more of those problems before we move to coordinate proofs. DF equals 12x minus 2. BC is 5x plus 4. Same given information. We got midpoints and midsegments. What is BC? So again, this one's 5x plus 4. This one is 12x minus 2. Right? And so we need to do 2 times the BC equals DF. And just plug it in. 2 times, this time it's over here, 5x plus 4, 12x minus 2. 10x plus 8 is 12x minus 2. Minus the 10x to get 2x. Move the 2 over. I get 10 is 2 times what number? X is 5. Again, got my final answer. What is BC? So I need to plug 5 back in here. 5 times 5 plus 4 gives me 29 is BC. Moving on to coordinate proofs. Coordinate proofs are exactly what it sounds like. We are doing proofs using the coordinate system. Now, what type of proofs could be done with the coordinate system? Right? We could find, midpoint. We could find slope. We could prove things are parallel. We could prove things are perpendicular. We could prove things like one side equals half another side, kind of like what we were just doing with the midsegment. So there's lots of different things we can do with proofs with coordinates. And now the difference is instead of having more of a given prove type situation, it's more going to be given, here's some points, prove that this side is half the other side, right? You're going to have to do the math of, okay, if I need distance, I'm going to need distance formula. So don't forget that we have several formulas, right? Distance is square root of a squared plus b squared when we can draw the right triangle, right? We've got slope formula, rise over run. Generally, if we need that, we can kind of do the counting method, right? Perpendicular is opposite reciprocal, right? Things like that we're going to need to take into consideration for doing it. And another important skill in this is placing points in a way that's going to make any type of proof we do a little bit easier. So starting off, place a square in a coordinate plane in a way that is convenient for finding side length. Right? Now what's easier, to use something kind of like this diamond looking shape of a square, or can we place the point in a way that we are using these perpendicular lines of the grids to help us out, right? So in this case, 4 to the right, 4 up, 4 to the left, 4 down. And if you needed to do distance formula, for the most part, we just need to count there, right? Instead of doing distance formula. So I would say it's more convenient to use the right angle of the grids to help yourself out. Now notice it also set assigned coordinates. right? So I'm going to start by using variables, but understand that it's not very different than if I use numbers, right? So if we start with 0, 0, right, because that's the origin, even if I'm using variables, let's say this side length was x, right? Well, we move x to the right, so this point must be x0. This other side also has to be x, because both sides need to be all the same, all four, and so they're all going to be x. Now, what's my difference here? I'm going to have to move x to the right and x up. So my points are 0, 0, x0, xx, and 0x. And often, when we use variables, sometimes instead of using x, they'll use like a, b, c, d to signify that they stand for a number. Now, maybe someone else decided they wanted to use, we'll change colors here, wanted to use actual numbers, and that would be okay, right? 4, 0, 4, 4, 0, 4. Just note that by using specific numbers, I'm generally proving this information just for that case. I'm not proving it for every different case. Whereas if I use variables, because those variables can be any number, I'm proving it for every situation. Next, place a rectangle in a coordinate way that is convenient for finding side lengths. So go ahead, try this one on your own, and then we'll see if you match me. So here's my answer. How do you do? Right? Now maybe you use numbers. If you use numbers, again, what if it was 6, 0, 6, 4, 0, 4, right? 0, 0, right? That's okay as well. But again, from this situation, we could kind of get into talking about why are diagonals congruent, right? So that's something we will learn later. Moving on. We got one more. This time it's an isosceles right triangle. There's a couple different ways you can do this one, but I am generally going to use my grid, right? 0, 0. I'm going to go whatever distance I go. Remember, isosceles means two sides are equal, right? So no matter how I draw this triangle, the one that's not equal is my hypotenuse. So I could do it this way, or someone might also want to do it maybe this way, where whatever you go, right? So either one of those is going to work. I'm going to stick with this way so that I have more zeros, because if I had to use a proof, then my numbers would be more zeros, more L's, right? For these legs are both the same. And then we find out if we had to, hypotenuse would be leg square root of 2. Right? You don't need that on there, but just letting you know. And then next it says, and the coordinates of its midpoint for the hypotenuse. So let me show you where that length square root of 2 came from. Okay, right? We went up L over L. We're basically doing distance between these 2 points. Well, we already have the two legs are both the same. So we're basically doing d equals the square root of that one's going to be my A, and this one's going to be my B. Doesn't matter which one's which, but I have L squared plus L squared. How many L squared do I have? I have 2 of them. And then just a reminder of how square roots work. If I can pull something out, and I have 2 of them, right? Like in this case, I have 2 L's, right? Just like the square root of 4, you can get a 2 out, right? You need 2 of them. So in this case, I can pull an L out, and then there's a 2 left over. One thing left over goes back underneath, so my distance here is L square root of 2 for that hypotenuse. The midpoint, and another thing we can find is where you would add the x's together. So 0 plus L divided by 2. Add the y's together. L plus 0 divided by 2. And what do you know? They're both L divided by 2, L divided by 2. Now, there are situations where it would help us, if we didn't want fractions, to pick something like 2L or an even number. Maybe we just called it 4, so that when we divide by 2, you know, we would get an even, a nice number, right? 4 divided by 2, 2. So one last one, and this is kind of getting into the proof side of it. Prove the quadrilateral 2, 1, 2, 5, 2, 1, 2, 3, 5, 5, 7, and 5, 3 is a parallelogram by using slopes. So what they're saying is show that opposite sides are parallel in this picture. So what they're wanting us to do is to show is AB parallel to CD, right? That's what they want. And then is BC parallel to AB, right? Those are the two questions they're asking. Well, this one's pretty quick to do because we can count, right? So what's the slope of AB, right? From here to here, I'm going 1, 2, 3, 4 up, 0 over. Slope's undefined. Okay, what about CD? Right, same story. 1, 2, 3, 4 up, 0 over, and the slope of CD, which is also undefined. So those are parallel. So we did AB parallel to CD. Check. 2 more lines to do. I just showed those are parallel. So for my next set, I'm going to do BC, which I'm counting. We go 1, 2, 3 over, 2 up. So now I have 3 over, 2 up on top. And then doing the same thing with AB. 1, 2, 3 over, 2 up, giving me 2 over 3. These are also equal, so they're also parallel. And therefore, yes, it's a parallelogram. Right, we would prove it. We got both our sets of slopes proven to show that it's a parallelogram. Next, and this is one that will be one you want to know how to do. This is one that I like putting on test, whether it's one piece of this, 2 pieces, or the whole deal, is proving what we just learned today with midsegments. Right, so given this information, we can prove, right, given the information, we can find J, find K, prove that they're parallel, and then prove that OA is equal to half JK. For this proof, I'll use actual numbers so you can see them a little easier, but let's figure out what our points are. So we got 0, 0, 2, 4, 6, 8, 0. And then A looks like it's 6, 2, 4, 6, 8. And now we need to use those values to find the midpoint of AB. So here's AB, right over here. The midpoint looks to be about right here, but let's check with the math. Again, we've got 6 plus 8 divided by 2. Halfway between 6 and 8 is 7. We've got 8 plus 0 divided by 2. Half of 8 is 4. And so now my midpoint J is 7, 4. So we're right on the right spot. So that one's checked off. Next, we need to find K, the midpoint of OB. Right, OB is this segment, and it's 8 long. We can count that. 1, 2, 3, 4, 5, 6, 7, 8. So where are we at? We're at 4. You could also do the math, but realize there's more zeros than numbers that aren't 0. So this would simply be 4, 0 for point K, right? So checking that one off. Now we need to show that OA is parallel to JK. So we're going to need to slope a couple times here. So starting off, let's slope using the points they gave us. So sloping between these two would simply be counting, right? Counting 6 over, and then up 2, 4, 6, 8. So we went up 8 over 6. Finding my slope here is 4/3 for the line OA. Still in the same spot. I need to find slope of JK. Same story, but I'm shorter here. 1, 2, 3 over. 1, 2, 3, 4 up. Over is the bottom number for run. Top number is rise. And we also got 4/3, which equals OA. So those are parallel, right? So both of the slopes match. Next, distance formula. Now, I picked out these points specifically so we wouldn't have to deal with extremely bad square roots. But we need distance of OA, distance of JK, and then verify that JK divided by 2 equals OA. And I have this written backwards. OA is the bigger piece. So this would be JK equals half OA. Better late than never, but catching it. Right? Because JK is a smaller piece. So now that we have JK equals half OA, right, we can get finding distance. So again, same idea. We're doing distance with these two numbers. Right? Again, we can count. Right? We went over 6, so this side of the triangle is 6, up 8. So in my distance formula, that's square root again. Order doesn't matter here, whether 6 is first or 8 is first. With the square root of those two numbers added together, 36 plus 64 gives me 100, and the square root of 100 is 10. See, it worked out nicely. Now we're doing the same thing with this other line right here. Right, we're going over 3, up 4. Where did we have those numbers before? And the same idea. So again, it's labeled here quick. This is OA. JK, same idea, but with 3 and 4. Square root of 3 squared plus 4 squared. 9 plus 16 is 25. Square root of 25 is 5. And then just to verify that we're checking this off, that JK is half, we do 5 equals half of 10. Yep, that's an easy math problem. And so that is showing, yes, JK equals half OA. And that concludes this lesson. Feel free to let me know if you have any questions and check Google Classroom for your homework assignment.